application of the vector equation with speed, time, and velocity. We already talked about how vectors are really helpful in 3 dimensions, and that's where we live. So anything that we do in 3 dimensions can be represented by vectors. Again, we can add some arrows. This is the vector equation of a line. Remember that the R is like any vector that ends, any position vector that ends on that line. The B vector here is your direction vector. That's sort of like y equals mx plus b. It's sort of like the slope of your vector. It's your direction. And the vector A is any point on your line. T is a scalar, and we'll find that in our application to speed, time, and velocity, we use t because t will often be time. So, here is the same thing in speed, time, and velocity. So again, R is a position vector of any point on that path of a moving object. We use A, though, as the position vector of a starting point because we're going to make t time. So if t is 0, then 0 times b would be 0, and you would just get the vector A. So that's going to be your starting point. And we call our direction vector our velocity vector because it will be how much you're going to move when t is 1. So the length of the vector b, the length of your velocity vector, will be the speed of the object. And it will tell you which direction and how far it's going. So here we have the magnitude or length of b is your speed. So we'll start off in 2 dimensions. We've got a moving object with one vector equation there, starting at 1, negative 1 plus t times 3, 4. So our direction vector, 3, 4 is our velocity vector. So the first question here, write down the velocity vector. That's 3, 4. The length a squared plus b squared. The length is 5. We look at time. Time here is measured in hours, and distance was measured in kilometers. So we can say that the speed of this object is 5 kilometers per hour. The object is traveling It's traveling 5 kilometers per hour in the direction of 3, 4. So very much like slope, we know that if you had a point here, if we drew this vector and we went 1, 2, 3 over and 1, 2, 3, 4 up, that's the direction that this object is moving, and we know that its speed is 5 kilometers per hour. So now it does make a difference how big we make our direction vector. Like if we wanted this to go 10 kilometers per hour, we'd have to double it and say that the direction vector was 6, 8. So when writing an equation of a line, it doesn't matter what values you have here, but in this application it would, because that's calculating its speed. So finally it says, can we give it in Cartesian form, ax plus by equals c? Well, right now we had the vector form. We could take the vector form and write the parametric. Negative plus 4t. And then from here, we could solve for t. So the first equation, subtract 1 and divide by 3. That would get t by itself. The second equation, add 1 and divide by 4. That gets our Cartesian, which has our x and our y and numbers. This is just some manipulation of y equals mx plus b for the Cartesian form. So now I'm going to take this equation, get rid of my fractions, multiply one side by 4. That'll give me 4x minus 4, the other side by 3 to get rid of the fractions. And it wants it in ax plus by, so I will put 4x and the minus 3y on one side. I'll add 4 to the other side. And it was just a matter of rearranging the equation. But it seemed a little bit different because it gave you a form that you're not like used to. You would have done much better on this question if it said, write it in the form y equals mx plus b, because you would have been triggered to think of the Cartesian form, okay? The Cartesian form is any form of the line with an x, a y, and a number, and it could be written in any way, right? Some ways are more helpful than others. Like y equals mx plus b is nice because it tells you the slope and the y-intercept. This form doesn't tell you anything, but doesn't have fractions. But maybe it would be nice for figuring out points, mental math-wise. You could see that, oh, I can see that 1 comma negative 1, mental math, that'll be 4 plus 3, that equals 7. I can see that that point's on the line. I can also see that that point's on the line really easily by the original question, because they told us that point was on the line in the original question. So this question, you have the parametric equations. From the parametric equations, you could write the vector equation. We'll do that here. We would know that the point is 4 comma 5. And the direction vector is 5 and negative 2. Oh, I'll do that in its right spot. There we go. So there's the vector equation. Write down the velocity vector. The velocity vector is 5 and negative 2. And the speed will be root 29. Again, we should look at what are the units used here. In this case, it is meters and seconds, so your speed will be the square root of 29 meters per second. What object is this? This is some bird that is flying, or some child that is walking. And they're walking on a straight path, and there happens to be a pole located at 39, negative 9. Will this small child walk into the pole or not? A little bit of foreshadowing. Today is going to be a disastrous day. So if we look at our parametric equations, because that is, we have got one parametric equation, and you will find that your parametric equations is where you do a lot of your solving. So we're wondering if there is right? This is always what you're asking, is if something's going to hit a point, is there a value for t that would get you to 39, -9? So I would plug in 39 for x. Move the 4 over, and I would get t is equal to 7. And of course, we could add our units, 7 seconds. And then I would plug in -9 for y and see if it gets the same t value. If the t value is different, then it doesn't intersect with that point, because there's no one t value that gets you in that direction to that point. But if the t value is the same, oh, this poor kid. Then the object collides with the pole. Personal experience, colliding with poles is not a positive thing. I collided with a pole when I was in grade 6. I've told you that story, right? Yeah. Okay. So at 7 seconds, the poor kid probably had figured out his own vector equation, but unfortunately couldn't solve it within 7 seconds and ran into the pole, right? Desperately looking down while walking to a piece of paper, trying to figure it out, and collided. Oh my goodness. Airplanes are a great example of where three-dimensional and lines come into play. Because most of the time, when airplanes are flying, they're flying in a straight line. They're not, you don't want to be on an airplane where you're probably like, you're like, oh, should we do like a sine graph for a while, guys? And they go up and down, then people aren't very happy. So mainly airplanes are they're flying in straight lines, especially when you only look at them over a short distance. Okay? Now, here's a jet flying at a speed of 700 kilometers in the direction of 2, 6, and -3. And we want to find the velocity vector. This is a direction vector, but it's not the velocity vector, because if we look at the length of 2, 6, and -3, what do we get? We get the square root of 4 plus 36 plus 9. We get 7. So the length of this vector is 7, and we want a vector in the same direction, but to have a length of 700. Now this one in particular is easy to do some mental math. How would you go from 7 to 700? You will see that you multiply easily by 100. So we can find our velocity vector, which I'm going to call b here, would just be 100 times 2, 6, and -3, or 200, 600, -300. Can you see, though, that sometimes there wouldn't, I could give you numbers that weren't easy to do mental math. Let's say you figured out the square root of this, the speed, and you found its speed to be the square root of 17, right? Now, is your mental math really good that you go, oh, I know exactly that square root of 17 times blah is 700? No. Okay? So what will often happen as an in-between step is is that you would find your unit vector Does that make sense? If you found your unit vector and then took this unit vector and multiplied it by 700, because this has a length of 1, you'll still get the same answer. This example, we could easily do the mental math, so it made sense to do that, but it's nice to think about, well, what if I couldn't do the mental math? What should I do as an in-between step? That in-between step would be, we can always find our unit vector by doing 1 divided by the length of the vector, and then take that and multiply it by whatever we want. Boat questions tend to be in 2 dimensions, because they're traveling on water, and unless it's really wavy, it's pretty flat. So a yacht leaves a harbor, and its position vector kilometers relative to the harbor at time t are given by the vector equation xy is t 5, 8. Notice there's no numbers in front because you would technically, if it's compared to the harbor is at 0, 0. The position vector of a cargo ship at time t hours is given by this vector. 6, 3 plus t 3, 7. Find the speed of the yacht. Okay, we're given in kilometers and hours here. So the speed of the direction vector of the, or the velocity vector of the yacht it is not going that fast. Somewhere between 9 and 10 kilometers per hour. They're just relaxing. The cargo ship is also trickling along. So when the pleasure boat, which is the yacht in this case, is starting its journey, which is at time equals 0, does it make sense that the cargo ship its starting position from the question was given as 6, 3. If we want to find the length of that vector, does it make sense that the length 0, 0 is the harbor, 1, 2, 3, 4, 5, 6, 1, 2, 3. Here's the cargo ship at 6, 3. How far away it is from the harbor would be the length of that vector. So if we figure out the length of 6, 3, the cargo ship is just under 7 kilometers away from the harbor. So these 2 boats are traveling extremely slowly and are far away. Bum, bum, bum. If the yacht and the cargo ship continued on the same courses, will they collide? So again, we can look at the parametric equations of the yacht. We'll do the yacht in black here. The yacht was 5t for x and 8t for y. And the cargo ship, I'll do in green, was 6 plus 3t, and the y value is 3 plus 7t. And what makes real life questions a little bit easier than some of the questions we did at applications earlier is when we did applications earlier, do you remember that one equation often had a t and the second equation had an s? And then you had to solve a systems of equations. But when you're dealing with real life problems and seeing if things are going to intersect or collide, your time is the same thing. The paths may cross, but if they cross at different times, that's no problem. It's only going to be a problem if the yacht and the cargo ship are at the same place at the same time. So from these ones, I can just say, well, 5t is equal to 6 plus 3t, and this one I can make the y values equivalent. 8t is equal to 3 plus 7t. And we need to solve for t in both of these, because if t is different, then they won't be colliding. But if t is the same, oh no. Slow, this is like, you can watch, we'll see, here we go. T is equal to 3, oh my goodness, t is equal to 3. It's like a 3-hour movie where you slowly watch these boats starting 7 kilometers apart, just under, traveling on a straight line. 3 hours later, they collide. We can add our units here. Now, it's not a good way to end vectors. We're having a lot of accidents. First, the kid walked into the pool. Now, 2 ships have collided. So sad. All right, sorry, lots of words in this one. I apologize as a math teacher. So our unit vectors of 1, 0, and 0, 1 are often used in these questions. In this case, they're telling about displacement either to the north or to the east. Because if you think of north, south, east, and west, 1 kilometer up would be 1 kilometer to the north, 1 kilometer to the right would be 1 kilometer east. And we've got a diagram where we put a lighthouse at the center that shows a circle with a radius of 25 kilometers. So you can see the lighthouse if you get to within 25 kilometers. Point P, we should actually draw it on. I have a P, but it's not in the right place. 31 kilometers west, 32 kilometers south. Here is point P. The ship is traveling parallel to 4-3, so that means it's going to go over 4, 1, 2, 3, 4, up 3, 1, 2, 3. This is its direction that it's traveling. With a speed of 20 kilometers per hour. If we wanted to write down the vector from O to P, well, we would go 31 to the left and 32 down. That would be the position vector of OP. Now this next question, when the questions are written this way, I find that there's often mistakes that are made, okay? Show that the path of the ship can be represented by the equation. That's what you want to show. And a mistake that's often made in a question where you're supposed to show something is students use what they're supposed to show and show that it works. But if you're supposed to show something, you're not allowed to use the answer, right? So if you use the answer to show the answer, it would be like, here it is. That's all you're doing. And so no marks is awarded for that. So instead, we have to think about this as, right, they're nice enough to give us the answer, but we can say, can we find the equation of the path of the ship? Okay? How would you find the vector equation of the path of the ship? We need two things. One, any point. We have this because we know that OP was negative 31, negative 32. And two, we need the velocity vector, our vector B. If we can find our velocity vector, then we'll be able to plug it in. Again, they've told us the answer. We know that the answer to the velocity vector should be 1612, right? But we can't take 1612 and say 1612 is parallel to 3,4 or 4,3 and has a length of 20, so we're good. That's not allowed, okay? Wow, that's a beautiful tree. I'm going to keep that. The length of 4,3 is 5. So you could find, if you wanted to, the unit vector in the direction of, I can't make a 3 like that again. It was just a pure chance. The unit vector in the direction of 4,3 would be 1/5 of 4,3. I almost did it again. And the velocity vector has a length of 20. So if we take 20 and multiply it by the unit vector, we're going to get a 4 out in front, which gives us the 1612. So again, the temptation would be, you see the 1612 and say, the velocity vector has to be 1612. Look, it works, therefore the equation is right. That wouldn't be given full marks because you've used the answer to find the answer. Okay? Instead, we used what we were given to find the answer, that is a proper mathematical way of showing something. Finally, we should write out the answer that they want us to find. Because this is what they wanted us to show. Now, we're going to just quickly go back to our picture here. If I have point P here, it tells us that in 1 hour, we are at point R. I'm not sure if that's where R is, but you're going to go over 16, that is a 6, up 12. Does that make sense? Because your direction vector is 16, 12. You would go over 16 and up 12. Could you figure out the coordinates of R easily from that? Yes. Okay? So you could go over 16, that will put you at negative 15. Up 12, that will put you at negative 20. So one way that you could solve for OR is that way. Negative 15, negative 20. Okay? You could also if it's in 1 hour, we could use our equation and plug in T as 1, because that's what our equation is doing. It's telling the path of the ship. You want to find any position vector on that line, you just have to plug in the time and find it that way as well. Does it make sense that P to R is just our direction vector? Again, looking at our diagram, this is P to R. So the shortcut for figuring out P to R is just say, well, you've gone 16 to the right and 12 up. P to R would be 16, 12. Of course, the other way that you could figure out P to R is you could go from P to O and then O to R. And we figured out, or we know that O to R is negative, oh sorry. I'm going to write like this. Negative O to P, because you would go back to the origin, so you go in the negative direction, plus O to R. So O to R is negative 20, subtract, and O to P is negative 31, negative 32. This will give you 1612 as well. Probably easier to see this if we think about negative P plus R. So we've always got this idea of vectors. We can go back to the origin, that's the negative of the vector, and then from the origin back to the other point, that is going from P to R. Show that when the ship reaches R, the lighthouse is visible. right? The beginning of the question said that the radius of the circle was 25. So anything within 25 kilometers will be visible. If we figure out the length, how far are you away when you're at R? If we figure out the length of OR, that would be the square root of, negative 15 squared, which is 225, plus 20 squared, which is 400. This is perfectly 25. And so it is visible for the first time because it reaches 25 at that moment. And we can't end the last unit without bringing in some negativity. A second ship is described by the other vector equation. Will the boats collide? I said on Friday that the last lesson was a little bit more disturbing. So you can put your predictions in here, but there seems to be a thing. Maybe we'll end on a positive note. There's always hope. So again, how do we find out if two things collide? We need to go to their equations and write out the parametric equation. So that for the first boat, or for the first ship, its parametric equation would be negative 31 plus 16t, and the second one, negative 32 plus 12t. For the second one, its parametric equations in green here would be x equals negative 7 plus 10t, and y is equal to 4 plus 3t. That would create the following. We could just substitute negative 31 plus 60 is equal to negative 7 plus 10t. And for the second one, negative 32 plus 12t is equal to 4 plus 3t. If the times are the same, then we end this unit with a disaster. If they are different, there's still hope. Okay, so solving for the first one, I got t is equal to 4. Is that what you got? Drum roll. Solving for the second one, oh no. T is equal to 4. They will collide at 4 hours. This would have been the sequel to the first movie you watched. This one's a little bit longer. Maybe came in 2 parts, but 2 ships on a straight line colliding after 4 hours. I mean, it could be an interesting movie. You could have these parallel stories of what's happening on the one boat, what's happening on the other boat, how situations on those boats cause the whole crew to not pay attention to where they're going.
Any Indigenous student who is also graduating this year who did not receive an invitation, please come down as well. Thank you.
Okay, so now we need to plan for something more hopeful, and let's figure out when we're going to do our test.